today we'll be talking about Git and GitHub. And everyone I've talked to about this who knows Git told me I'm absolutely crazy for giving a 1-hour course in this. We would usually need like 2 days to cover this. But the idea is to give you like a concept of what this thing is and like the absolute like bare minimum basics of how we interact with Git. And whenever you need to do something that is beyond what I teach you today, Google is your friend. It's my friend because I know like 4 commands in Git, and that's like what gets me through every day use of it. And the rest is like maddeningly complicated and weird. And whenever we touch it, we have no idea what we're doing. We're just kind of praying to the technology gods that it does what we intended it to do. So yeah, this is a crash course. Very, very, very much so. So this is what we've covered before. We've talked about RStudio projects. We've talked a bit about organizing your files and your workflow based on that. And we've talked a little bit about package and library management in R. All those talks are online. All the materials are available online. So anyone who either doesn't remember or wasn't here then, you're welcome to see them then there and ask if things are unclear. So today is the Git and the GitHub super crash course. I could probably add like 100 superlatives on how crashy this course is going to be. And I added part 5 today, so that's going to be on the Tuesday in May, because all the Thursday meetings are actually booked until the end of the academic year, which is great. Which meant that I want this last shop I wanted to hold this semester will be on a Tuesday instead. But it's in the LCBC calendar, so I'll also write it in the channel, that channel, what day I booked that in. There was nothing else that day, so I kind of assumed that it was probably a good thing. And then we'll be talking about R Markdown, or the latest new thing in R Markdown, which is Quarto. I've been saying this word a lot. So Git stands for General Information Tracking. And it's about general information tracking. So it's a version control system, and there are several different types of version control systems. Git has become pretty much the default system that most people use. It's pretty clean. So it tracks changes in files and folders that it's been told to track. So you have to tell it what to track, and then it will start tracking the changes to those files and folders as you make them. It is particularly well suited to tracking text files. Any other file it's tracking, it will like take a new snapshot of the entire file every time you ask it to update. But in text files, it's extremely clever in that it only tracks the changes in the text in a line-by-line fashion. So if a single character is changed on a single line in the text file, that's the only change that it's tracked, that there's a single line change. And that's why Git is so powerful, is because it only tracks the actual change, not the entire file every time. So the file size of a Git repository isn't necessarily very large, because it only tracks the change, not the entire file content every time you save. It is command line based, but today we'll be using the user interface through RStudio as like the friendlier introduction to it. But basically anything we do in RStudio is translatable to actual command line text that is run in the background. So why do we have this thing called Git like we're the Dropbox? Dropbox just stores everything. Dropbox is a type of version control system. It has its own like little way of doing things. It's basically the same, just Dropbox does it natively for you without you telling it to do anything. You just put it there and it starts tracking. In Git, we have to work a little bit more, and that's kind of good. So every file you've asked it to track, you have to ask it to track it. You have to be a bit more conscious of what you're doing. It will track. It tracks them with comments. So it's not like Dropbox, you just ask it and it will track it, and it doesn't know why you're doing changes or who might be doing the changes in the specific file. It just tracks the changes. Git will always store who made the change and whatever comment they made go with this change. Yeah, and with a timestamp. It's a like really nice way of like understanding like the development, the history of a file, and who's been doing what on the file and when and why. Well, the why depends on how good the comment is. So that is that kind of depends. All changes can be undone, even without losing history of whatever it was. We can also choose to lose history if we want to. It's just a really complicated affair, but we can do it, and we have done it when we had data breaches by accident. It can handle when changes from different users collide. So say two people have been working on similar things and their lines collide with someone's been working on a manuscript. I've made some change to a sentence because I thought that was better. And then Stina was working on a copy of the same thing I was working a copy of, and she made a different change to that sentence. And then we try to merge them, and the program will go, hey, both you guys made a change to this line. They're not the same, and I don't know which one to choose. And then we have to manually choose, do we keep Stina's version or do we keep my version? Without losing the changes I made or the changes Stina made, we just have to choose which one of them we want to continue working on after that point. So we really can save everything, and just because we're only saving the changes, the storage space needed for this is quite small. It doesn't mean we can't make it big. We can. Knut has like a huge one on GitHub, but that's because he has a lot of files that are not text-based. So when they change, the entire file is copied into history, and so that can very, very quickly create a very, very large space. So I should probably I don't need my break reminders while I'm having a talk. So let's pause that for a bit. Sorry about that. So before I even talk about some lingo, Git workflows are very often visualized in this kind of manner. So let's imagine that this black line, this is like the main development of some, I don't know, paper we're working on. We're working on making a paper, and this is like the repository we have with all our scripts and the stuff that we're working on together to figure out. And it contains some files. It contains an analysis script and maybe a manuscript and some stuff. And then I create something called a branch, which is like a clone, a copy of the original repository, which is here. And I start working on fixing some depression calculation that wasn't working correctly in my own copy of it. And then Knut takes another copy of the same thing and works on an analysis for zygosity in the twins. So now Knut and I are working on, based on the exact same information that we have the exact same information, but we've started working on our own separate things. So what I'm working on, Knut doesn't have access to, and what Knut is working on, I don't have access to. So we're working on different places. And at some point I say, okay, I'm pretty happy. I make 2 changes that make the VDI calculations work. And then I merge my changes back into the main so that, oh yeah, I keep forgetting that this is a touch screen. Can I do this? Hi, yeah, cool. That actually worked. Not as I wanted it to, though. How do I make like that? I have no idea what I did. Full screen. Okay, sorry. And then Knut works on his stuff, and then he merges into like the main repository right after I do. And suddenly, this point in time here, the repository contains both my fix to the BDI and Knut's analysis script, and Jonas's temporary zygosity work, for instance. And it's all of this is like the history is maintained for everything. So here we know exactly what I worked on, what Knut worked on, and what Jonas worked on, and what files go where. And we kind of kept the history of all of it. So how does GitHub come into that? So remember, we talked a little bit about it in the beginning, how R and RStudio are two different things. So R is a statistical program that is like the bare bone who's doing all the stuff, and RStudio is an interface towards the program. We can interface to R through other things, but RStudio is now like the dominant user interface towards R. So GitHub is like a cloud user interface towards Git. So Git works locally on your computer. Well, GitHub is where you can send your entire Git information from your local computer into a cloud storage, which is GitHub, and there you can easily share it with other people and work on it. So I've called it cloud storage. I don't know if GitHub would agree that it's a type of cloud storage, but I think it is technically, and it stores any type of Git data. That like anything else, it doesn't know really that is what it's for. It stores Git data. And it's also an online Git collaboration platform. So there are ways that you can work on GitHub just through like the browser doing lots of stuff without needing to work on like a local command line kind of thing. So why do we want GitHub? I mean, we want GitHub so that we can work collaboratively together through like a single source, but we could have chosen any of a number of other services that do exactly the same thing. Like GitLab is very popular, Bitbucket, Git, which is what we have on TSE. It's like a GitHub-like thing, but it's just something else that we could set up ourselves. So GitHub has just become very the dominant, I would say, cloud storage for Git repositories. And then it has a lot of other products attached to it that makes it very powerful. And in LCBC, we chose to use GitHub, and we have our own organizational account there. So if you're doing Git and GitHub things for products for work, I would very much recommend setting that up in the LCBC organizational repository rather than your personal one. I can sometimes start in my personal one and then I'll move it over to LCBC because it's a work product and it should be there. So when we work, it's like good to have this idea that locally on our computers we work with Git, and then periodically we send all of the Git information up to GitHub to be stored securely in the cloud for us and for other of our collaborators, so we're able to have access to our temporary work and can work further on it. So Git is local on your computer, GitHub is in the cloud. What we very often talk about is that when you work with Git on your local computer and you have things up in the cloud, you're working on a branch of like the main repository that is up there. All right. So I just wanted to give an example of a way we work with Git and GitHub, or in this case Git, because it's on TSD. is for the NUAS data repository, which is like, for people who have been here long enough, the NUAS is where like we have all the LCBC data, right? And most of us are used to working with the NUAS through this web application we made on TSD that you can select the data and stuff. In the background, the data for the NUAS is actually stored in the Git repository on TSD. And the Git repository always has two branches that are mandatory. So master is like the main branch of where we get our data. It's the most curated version of the data. It's been thoroughly checked. Everything works as it should. But when those of us who work with like updating the data or adding new data, we only ever interface with what we call the live branch, which is the default kind of working branch we're on, where things are temporarily placed until one of the main data managers, which would be me, Inge, or even Jamila has access to this, even though I don't think she's ever done it, can merge it into the master branch to live there instead. And we always work on our own personal branches until we fix something, and then we pull that into live. And then live has been working for a little while, and we're sure that it's kind of stable. It's not, we haven't broken anything, like the data is still secure. Then we'll merge that further into master. And then we know that master, the main NUAS data is always like up and running and working, while both live and all the other stuff here, we periodically break by accident. But because we have this system that you can never work directly with master, we can't break it easily. Like I have to try. I obviously will not try to break master. Yeah.
Just a question in the chat.
There's I can't. No, wait, this is mine. I think it's just, yeah, it's okay.
Okay.
Do I even have this mouse? No, I don't. I think it's just still telling me I can share my screen from before. Yeah, but now I'm using all these words that are unfamiliar. So I'll go through a little bit of lingo before we start actually doing something. So a repository or a repo, which is often concatenated too because it's a long word, is a Git project. It has a .git folder somewhere that stores all the history of files, which you don't ever have to go into it, but just know that it's there. So any project that has a .git folder in it is a repository. If it's locally, if it's in the cloud on GitHub or GitLab or wherever, as long as it has a .git folder, it is a Git repository. So a clone, can I get away? I'm not happy with how things look here, but we'll just go with it. So sometimes we talk about cloning a repository, means taking a copy of an existing repository so that you can work with it somewhere else. Or, and usually it means taking, cloning a repository that exists on GitHub so that you can have it on your local machine and work with it. On GitHub or on other cloud services, sometimes we talk about forking repositories, which is basically a clone into another cloud service. So for instance, taking one of the LCBC repositories and then forking it means cloning that repository into your personal account so that you can work with it from there rather than directly in the organizational account. That's pretty, I mean, you don't have to do that because you have access to the organizational accounts. That's something we do sometimes if we find a bug in someone else's program and we know how to fix it. So we fork the repository, we fix it, we put it in our own, and then we request for our version to be added to the official original one later. So let's say you've already cloned something to your local computer and then Knut makes some changes and places it up on GitHub. So now yours is suddenly like out of sync and you want Knut's changes for what you're working on. You're like, oh, he did something really smart. So I want to build on his. You can pull that change into your computer. That's what pull means. So you pull, so you update what you already have with what's been placed on GitHub before. And then you can push, which pushes it from your local computer and up to GitHub or GitLab or whatever. And then we have something called a pull request. So a pull request is something you do when you have something in a branch, or, and I'll go through what a branch is very soon, in a branch or in a forked repository, and you request for it to be pulled back into the main repository. So if we're looking at the nuance, going from here to here is a pull request. So you request for someone to take this data and place it into the main branch of the repository. It's basically saying, hey, human who owns this repository, I made some changes, have a look at it and merge it into your data so that my bug fix or whatever gets implemented. Oh yeah, so, and a branch, so all of these other, actually all of these colors are different branches. So even live, which in this case is the master branch, actually live, which is the default branch to work in, is a branch. So they're all like copies or clones of the repository that people are working on. And we do that in branches so that we try not to work directly in like the default branch so that we don't accidentally break the default branch without knowing it. Yeah, am I making any sense? Branches are really like weird things to explain. Making sense-ish, kind of, almost. Okay, so remember I said like you have to ask Git to start tracking a file, and you do that by adding it. You explicitly say, hey Git, I want you to track everything I'm doing in this file. You add it to the repository. When it's just added, it's actually, so this is like the part of Git that is the most complicated to teach. So there are basically 3 stages a file can be in Git's kind of way of working. It can be untracked. I hope this is fairly self-explanatory. It's untracked, so Git is not paying any attention to it. It can be tracked, so it knows it's there. It's taking like an initial, it saved its initial state and knows what it contains. And it can be something called staged, which in this case I also have called the cache because people use different names. Stage is usually the one people call. So you can have something staged, but not officially tracked yet. And this is where the commit comes in. So in Git, when you add something, it's placed in the staged area. So it's like Git has been made aware of its existence, but you haven't actually told Git explicitly like, and yeah, I totally want you to actually start following this file. You do that when you commit it. So like you're committing it to become a part of the repository. While it's staged, you can discard it. And the history won't even acknowledge that you've done anything with it. Once it's staged and committed, once it's committed, it's in the history, and you have to actively try to remove it, which is really, really hard to get rid of the file and the tracking of it. When we start doing this interactively, this distinction will become a little bit clearer. But do remember that even though you've added something, it doesn't mean Git is fully tracking it yet. You have to commit it as well. So there's a two-stage process always. And before we start doing anything interactively, I just wanted to point out we have ways of adding like everything. Like you're in a folder and you say git add asterisk or dot means just add everything. And we usually do that when like we're at the start of a project and you don't want to like manually add each and every file because maybe there's a lot of files and that's just annoying. You want to add it all, but there are files that we maybe don't want to add for like they contain data or something more sensitive, and that's where the git ignore file comes in, which is basically a file that lists everything Git should never add, even though you're saying add everything. So mine usually looks something like this, like don't ever add anything that's in my data folder, because that's very likely going to contain human cognitive data. I don't want that put online. Maybe I have my own little personal file that can contain some comments that can be kind of identifiable of people in my data set. Like I have comments saying, who, by the way, this guy, this ID had something weird. Don't like just my own thoughts about my project that I don't want to share, but it's nice for me to kind of keep track of. And then there's some R stuff I always ignore because there's no use in having them tracked by Git. And then Mac creates these like hidden DS store files, which there is also no reason for me to have in my Git repository. So I just make sure that it's never tracked. So that means that anything I put in data, I can put anything there. If I'm working in this secure location and I'm allowed to have data in this repository, like if I'm working on the lagringshotell, I very likely have data in this repository, in this folder. I don't have to be afraid of Git suddenly deciding to track it because I wrote something I didn't mean to. And then suddenly I have placed LCBC data online. Probably not so cool. Then I'd have to do the like really annoying part of figuring out how to delete Git history, which is possible, but it's like a bit much. So if I can avoid it, that's good. So we have ways of making sure that Git never like tracks things you really never want to put in there.
It still seems a bit dangerous, unnecessarily so, to just ignore the data folder, because it could be quite easy to make a mistake in the Git ignore, right?
Yeah, you could.
Obviously, yeah, you be careful, but
yeah.
Still, if everyone is doing that,
yeah,
it might lead to an issue.
It might
later on.
Yeah.
Yeah.
But in general, I haven't seen a lot of projects that they're actually dead in there. But I mean, I do, but I have full control. So I'm pretty secure in that. But in general, don't use the add everything kind of command, and then you're pretty safe. If you add single files one at a time, which is like what you should be doing, then you're safe. Then you wouldn't be adding things by mistake. But if you do,
what about if you were late changing the Git ignore, say like in a text editor, and you accidentally like added a letter to the data thing when you were adding something else in the Git ignore, so it became data X or something like that, and then you added and committed.
Yeah. Then you'll have to go through the annoying part of removing it from history, which is totally possible, like totally fine. If it's a single commit, it's actually not that difficult to remove. It's much worse if it's pervasive around many commits, like you didn't notice for like a year. It's been there and it's been updating, because then it's a year of history you have to search through and remove. If it's a single commit, there is a command to just say revert it, like go back and forget I even made this, like, and then it will be gone.
Yeah,
it's no longer in the history. So there are absolute ways of dealing with this. And if you by some reason accidentally do add it and then actually put it online, and you don't know how to remove it, the first thing to do is on GitHub, there's like 2 categories of repositories. It's public and it's private. Just make your repository private and tell me and we will help you fix it. That's like, it's not a crisis. We have ways of solving it. just let us know. Everyone makes mistakes.
Hmm.
Literally everyone makes mistakes. Just let us know and we'll fix it. I've deleted Git, a lot of Git histories in my life. Well, my last 2 years of working actively with this program. So there are ways of dealing with it, but after like initial commit of a project, start working with adding single files rather than trying to add everything, and then you're pretty safe. Before we start working, you'll have the slides, and I'll put this in. There's lots of nice resources on how to work happily with Git and R. Actually, I've only been through the first part of Happy Git with R, and I learned so much already. So I'm looking forward to going through the rest of it, because Git is a there is a lot of complicated stuff in there, and I feel like I've already like dumped a lot of technical weird terms, and you have no idea what I'm talking about. But really, like the core thing here is to start a Git repository, add things to it, commit with a message, and then push it to GitHub. That's like with those 4 things, you can do like 90% of what you need to do. And then the rest of the 10% is on a periodic shit, I did something wrong basis. Okay, so I am going to start a new project. So earlier today, I made some changes to the LCBC package, so that we could initiate projects even better. And maybe I should ask you to install that before I start. And I don't remember that. Why is it being so volatile? I'm gonna put this on Slack, and it's gonna take like 2 seconds to run. For those who want to install the LCBC package, which has like convenience functions, mostly template files for R people in LCBC.
But this is not on TSD, no?
This is not on TSD. You cannot use the. It's not available on TSD, unfortunately. But there, you can just initiate the normal. I'll try to port it into TSD and get it installed. It shouldn't actually be that hard. It doesn't require a lot of this package at all. So here, so you actually see that? I'll start a new project. I'll put it in a new directory because it is, if the LCBC package installed correctly, hopefully. Somewhere down the line in the creating a project wizard, there should be. Can I make this bigger? No. I feel like there was a shortcut to make this bigger once. There should be like a thing where you can make an LCBC project. I'm hoping.
Git Ignore is better.
Huh?
The Git Ignore is better now.
Git Ignore is better now. Yeah, I could do the thing which made me go like, oh, right, I need to add some stuff to the Git Ignore. So I'm gonna create an LCBC paper project. I'm just gonna call it the LCBC test now, and I'm gonna call it. So there are 2 like tick marks here that I made. One to use Git version control, that will be always ticked off by default. So it will initiate Git for you and start tracking your files. And then there's also the possibility of using the RM package manager if you want. I'm not going to do that right now because I'm not going to do a lot in this very temporary project I'm making. Hopefully, if you create a project, it will do a bit of a think and a bit of a restart. And the project is up and running. Yes, no?
I was.
Yeah.
So which, so I create new project, we can put.
Yeah.
You took it away.
Here, new project.
New project.
I used a new directory.
new
And then
directory.
hopefully if the LCBCR package installed at the fairly bottom, there
I
should
can
be
see- I see where it comes from.
Yeah.
Thank you, create art. Yeah.
create LCBC page.
What's the difference between create LCBC project and create normal project without?
It's pre-populated with a little bit of extra stuff. Oh, I didn't spell LCBC right to that. Yay on me. It's really nice. Yeah, it's pre-populated with, for instance, a description and some folders like the docs and the figures and the scripts and results and the data. And that Git Ignore is also pre-populated with some information. Like it will automatically ignore data and results, and it will ignore some common file extensions in certain folders that will inflate the size of the repository. You can still force add files like this, like even though it's generally ignoring, you can still ask it to track files that have these properties if you want to, and then ignoring the art history and project. So it's basically an attempt to create a more like general way of working with paper projects in R for LCBC, so that we all try to adopt a more similar way of working. So maybe it's easier over time for all of us to work in each other's projects. Basically, that was the idea that Knut had, and I agreed with.
What does the double asterisk do on the DS store? Does it search
It should.
recursively in every?
It should.
Yeah.
If it actually works, I'm a bit more unsure of.
Right.
But in theory, it should. Yeah. Florian told me.
Huh.
Yeah, and there's a pre-created README file where you should write your stuff about the project. So as you can see, I hope you can see, there's already a .git folder. So the files are tracked by Git. Nope.
I see Git Ignore, but before that, the Git.
Maybe you're not seeing hidden. No, but if you see Git Ignore,
I see Git Ignore. I'm looking at it. Before it, you have Git, then you have Git.
then Git might not be properly installed on your system. Are more people seeing that?
I don't have it.
No.
Me neither.
Cool. Then we need to check if Git is installed. Yeah,
Yeah.
it was a possibility. So I need to remove it.
Do you mean the library which we should have installed before?
Yeah, well, in theory, that should have helped
Yeah.
us get things installed, but I'm not sure if it did.
I had it.
So if you write,
Yeah.
now, okay, this I can make bigger. Okay, there we go. So if you're in your console, write this, Gert, a double colon, Git underscore info. I can make it even bigger. Can I make it? Is that better? Yeah.
Error, no package calls here.
Did it install without error? Do you know?
I remember it was installed. Yeah, but.
Okay, we'll have a look. So if I, yeah. Actually, that wasn't what I expected it to be. Ignore, and now I can. So much stuff you can do in Git. I don't know what happened.
The package Git is not available for this version of R.
Do you write Gert?
Yes. Yes. T-I.
No, E.
Okay.
The Git info did not give me what I wanted. So everyone on a Mac should be able to do this in their terminal. So next to the console, there should be a terminal tab.
Okay, now.
And everyone's on, oh my God, I'm so happy. Wait, someone's on a Windows machine in their office, which is harder. I will help you, Electra, if it doesn't work. I'm a bit more unsure of how to check this.
So we need to run this package now.
Let me check. If anyone runs that in their terminal and you get a version back, that should be working.
Yes, it's, I think it gave me last.
Yeah.
Before, yeah, for workshop it gave me this.
No, but it's okay.
Yeah.
I can work with that.
I
Okay.
still don't have Git.
No, you have a relationship.
I
You
have
have
a,
it? Yeah, okay, fine. Good. Okay. So, did you hear it out? Anyone else? Still missing?
still missing.
Yeah, like I never work on this laptop, so I don't really use it that much.
Okay,
But I get an error when I run the Git, do the command Git version.
Okay, second question. Do you have Homebrew installed?
Maybe I did in the beginning, if I remember.
If you run brew install Git, I mean, that's either going to work or not. I really thought that thing we did should have worked, but then I was overly optimistic, obviously. I tend to be.
Should I do this?
No, you're fine. You have it installed.
Yeah.
You just have some global options missing, so that's okay. Or you might need to restart RStudio though, to get it to detect it. Which is another issue. Yeah. Ja. Men Git er jo installert.
Ja, den er
Det er jo på en måte
installert.
greit.
Ja,
Den bare
det er
trykker på
Ja,
der.
ikke den.
Det er jo neste
Nei, så er det restart.
Men du får opp Git. Ja, den er der. Den er hvor you're fine. Okay, so apparently second check.
Could not find the repository.
This is not initiated properly for you.
Oh, I'm now running it, so. I
Couldn't find a repository.
You could find this. Check.
I missed a step.
You shouldn't have to need this.
Git folder.
Why is it populating with me and not with you guys? Probably because I set it up. I've set up a project installation file incorrectly, so which makes it works locally on mine because I'm the developer. So obviously it will work with me and not with anyone else. That's always great. I will try to figure that out. But we have ways of getting Git to initiate. So if we load in the Git library, which is a Git interfacing library called Git, it gives us a little bit of information about stuff. So I've registered some stuff about me on my Git, so it knows my name. It knows that I have a global config. I have the SSH stuff. This is probably very different from you. I'm assuming this is going to say no for most of you.
Yes.
It does.
Yeah, I've got this in.
Oh, that's interesting. And cool. So a way to force Git to initiate, and I will make sure that my package works later, is to type git_init and then parentheses, which should initiate Git in your project.
Sorry,
Yeah.
the LCBC was not installing for me.
It's not installing for you. You have a problem indexing it. That's interesting. It has binaries. That's actually new for me.
I can continue without
Yeah.
those,
You can. I mean, you can
problems,
use the terminal if you want
Yeah.
and stuff, which is something I often do. So for those who, for some reason, I mean, but you got Gherk installed, right?
Yeah.
Yeah. So, yeah, I'm not going to. I mean, I can do this, but it's going to tell me it's already didn't do anything. Did it tell you guys something when it initiated? No, it just did. Okay, fine. So if we run
Yeah.
git info now, I'm assuming it's going to give you a path and some stuff. Yeah, so now it's doing something. Okay, so, but this is like stuff we actually don't want to deal with. And I'm sorry for not having like the default setup of my panes. So this might be a bit confusing. So there are two places you can access Git through the user interface without typing. It's either up here where it says Git with colorful letters, where you can't see it because there's a zoom thingamajiggy in the way. Pretty awesome. There's some stuff here. There is also a Git Pane, which is usually, I think, in the top right-hand corner by default. For me, it's in the bottom right-hand corner. And for me right now, everything has status question mark. Does everyone have it?
No.
Not everyone has this pane, then you might have an old RStudio.
Yeah.
I mean, it has to be really old RStudio. Like, I would be very surprised if your RStudio was that old. So I'm on the newest stable version. I'm on 22.1.
It's a bit older, but not that old. September last year.
No, it should have Git capabilities then. So then I'm a bit more unsure. What if you? No, because yeah. If you go to View, Panes, and then Pane Layout. For those who can't see the Git pane, View, Panes, Pane Layout. And then you get this thing. There's a thing called VCS, which is the one that toggles Git. Put it somewhere.
Yeah, there it is.
It took me a while to realize that VCS was the one that toggles Git, and I'm not quite sure why.
So view panes and then which one?
View,
Oh, I'm
Panes,
sorry, I'm in the wrong thing.
Pane Layout,
This is global options. Yeah.
or you can go to Global Options, yeah.
Right.
Global Options, Pane Layout, and then make sure you have VCS in one of these. Did it pop up then? Still no? God damn it. Okay, can we figure that out later?
Yeah, you have it.
Yeah?
Yeah.
Okay, fix it for one. That's like one step in the right direction. Oh, the Zoom thing is so in the way. Go away. Okay, so for those who still don't have it, I'll look at it with you afterwards, and hopefully you can still follow along. So, okay. So right now, all the files I have and the folders I have in my project, they have status question mark. Status question mark means Git doesn't know what to do though. That's like RStudio's way of saying I'm not tracking this. So we can start by tracking the Git Ignore, and actually we're not tracking it yet. So now we've staged it. Remember I said there's like two. There are 2 steps to actually putting it into the history. You first have to stage it, add it, and then you have to commit it. So I've told it like, okay, this is something I want to add. And then I can click the commit. So it says commit pending changes. Sure. Commit, and then it opens a dialog. It shows me what I want to add. So this is like all the content of the file. It's all green for now. I will show you what it means that it's green later. And I'm going to say, add a comment with this committing, like adding this file going to be amazingly enough and Git Ignore. Not necessarily the most amazing comments to add with it, but that's what we're doing. So that's what we're saying. Commit it. And then it's going to do a bit of a think. And then it's done. One file changed with 27 insertions. Created Git Ignore. And close it, and I'm in full screen mode, so this is a bit. Is that going to close RStudio or just this thing? Okay, just the thing. I didn't know. And now the .git ignore is no longer in my pane because Git is tracking it and there are no changes in it. So it's like, I have it. Don't worry about it. You don't need to do anything. You know exactly what's there. Cool. So if I do make a change, let's say, I know that I'm only going to put aggregated results in my results. It's not going to be like single participant anything. So I wanted to track the results folder. I have a clear idea of what I'm going to use this folder for. So I'm going to amend my Git Ignore so that I can easily add stuff in the results folder. So I take away the line saying you should ignore results, and I save it. And why aren't you updating? We have to do the. There we go. I just had to express. I just had to ask, add it to refresh, and then suddenly Git Ignore is back in here, and it has a tag M, which stands for modified. So, hey Moo, I'm tracking this file for you. You made a change, but you haven't actually saved the change in the Git history yet. Just so you know, it's modified, but I don't know about. You haven't told me to save it in Git history yet.
Where did you press to?
I pressed this kind of curly arrow thingy, circle arrow thingy. Refresh the
So if you make a
listing.
new project and take the initial Git and I think well, I didn't have a Git tab at first, but that was because I associated an existing directory with a repository. And with the new project, and it didn't have the option to initialize with Git.
Oh,
But then when you start a new one and initialize with Git, then the Git tab is there.
okay.
Maybe that fixes it for me anyway.
Okay.
But yeah.
Why is also initialized?
Yours is probably something weird. There's always one.
Yeah.
There's always one that has like something weird in it. For once, it's not Christina because she's not here. So, so to add the new modifications I made, I need to stage it. I need to say I want to commit it. It's going to open the dialog, and this time the dialog looks different than before. So before it was all green, because green means you're adding something new. Red means you're taking something away. So here it's telling me, hey, you're taking away this line saying results. White means it stays the same as before, basically. So, So this is how Git keeps track of it. And it even tells us, so like before results was on line 9, and now we're taking it away. So the rest is shifted up. So line 9 now becomes empty, and then it starts tracking from then on. So it really does keep track of just the change. And this is what's going to be saved in the Git history, that line number 9 was removed, and the content of line number 9 that was removed. That's it. Nothing else is kept in the history, just that single thing. And I'm going to say keep now. Yeah, track results. And I'm going to commit that. And it's
Doesn't
done.
appear in my when
No?
in this list of files, I took away results.
You need to save the file on your local computer. Yes, and then refresh. And now it knows. Yeah. So there's a little bit of an extra kind of step here, because for Git to know that something's changed, it must have also be saved on the computer. Like the local machine needs to know everything that you've just done in RStudio without saving it. Nothing actually knows that it's been saved yet. Not even RStudio knows technically that it's been saved yet. So you always need to save and then save and commit. So the process is a little bit longer, obviously, but it also means that we're a bit more aware of like what we're saving and how we're saving it, which is good. Now, I don't have to only add one in one file. I can add several things at once. So I'm just gonna add everything else. That's gonna add everything I have. I'm gonna commit and I'm gonna say start project. And then it's added everything that's not in the Git Ignore. And so now my Git Pane is empty because I've added everything. Everything is being tracked. Everything is paid attention to. So let's kind of check that it's ignoring the data folder the way we're expecting it to ignore the data folder. Let's make a file in the data folder. We can make a text file. A simple text file. And we're just going to say some blah blah in it. You can write whatever you want. We're not committing it to history, so you can be as stupid as you want. No one's ever going to know. And we're going to put it in the data folder. And I'm going to call it test.txt. So now I'm adding a new file into the data folder, which Git has been told it should just ignore the content of. So if I add it, so let's check that it was placed there. So we go to the data folder. Okay, so the test.txt file exists in the data folder. And if we have a look at Git, I ask it to refresh, the file is not there. So it really is ignoring it. I can ask it to add everything in my repository, but Git's not going to add that file because it's just going, I'm ignoring it. I don't know. I don't know you exist.
So it's in the data folder, but not in the repository.
Yeah.
And
So
it's a Git now. It's still on my computer. It's not going into.
not going anywhere. And that's the thing. So when we send Git up to GitHub, it's just going to send the stuff that's associated with Git. So everything Git is tracking in its history. So even if we're in this folder and we push it to GitHub, the data folder is still not going to go there because Git is ignoring it. And we're only pushing the Git repository to GitHub, not the entire project folder. So there's a difference between your project folder and the Git repository. The project folder most likely contains more than the Git repository is. Is that making sense? All right, so I'm gonna, what time is it? I have no idea. Yeah, I'm over time, so do you want me to continue a bit more, or have I filled your brains full of stuff you have no idea how it works? This is like the main thing. You do stuff, You add, you commit, you continue working, you add, you commit.
And we can push things to GitHub. It's not gonna work now because I don't have a repository and it's going to complain. So I'm gonna make a repository on GitHub so I can test it. I'll make it here. I'm gonna make a new repository called LCBC. I'm gonna let it be. There's lots of stuff here.
If you already have a local Git repository that you want to send to GitHub, ever click on any of these things, because you will have something Git calls conflicting histories, and we don't want to deal with that. It's a pain to deal with. Just don't do it. If you have a project already locally that you just want to send that up to GitHub, just skip all of this stuff here and just create the repository.
Do you need an account here? Or
Yes.
Do I already have it automatically by?
You don't have it automatically. You make an account, but it's free. And if you have an account or you make an account, let me know, and I will add you to the LCBC organization as well, so you have access to the organizational account. Let me know your username, and I will add you.
But I will have to create my own account, not organization.
Yes,
They're not connected.
yeah, you make your own account. Yeah, and then just whatever you want to call yourself. I call myself Afanasiam. That's what it became a long time ago. So now I've made a repository here, and it has no content because I didn't add any of the files that GitHub allows you to add by default. So I'm going to use this option here. I never remember this part by heart. I always just copy this. Because I just can't remember it. So I just copy this bit of code and I go to my I go to the terminal in my R project and I paste it. And then I let it do its job. Branch main is set up to track origin main, and origin main just means this. And now all my files are in the cloud. You can see no data folder. And from here, you can all clone it, have fun, do whatever. There's no content in this. I didn't even render the README correctly, so it looks crappy. But so this is out. So despite me actually working a lot with Git, there are stuff I can't be bothered learning by heart, like that piece of code to push something locally up to GitHub for the first time, because I mean, GitHub's very nice. The code is there, so I can just copy paste it. No reason to spend time learning something. I can just copy paste. But from now on, this repository knows where to send the GitHub information. It says it looks a bit weird, but it says it has a remote and it has an upstream. Before those was just null and NAs. So now no. So every time I say git push, now I mean it's gonna say nothing. It's gonna say, you see, status is unchanged, so it's not actually gonna push anything, but it knew where to look. So I don't have to deal with it. It's set once and for all. It's just fixed. I don't have to deal with it anymore. It knows where it is. So working with the Git Pane in R is quite nice. Because you don't have to learn all the commands by heart. If you do want to learn the commands, I gave you some resources, so they are there. I tried to use similar type of language as the commands are, so that they are a bit familiar.
but really, like the biggest test of Git and working with it is when you start to collaborate and you're like working on different parts of the project simultaneously and you start merging things. So I think once we've all worked a little bit with Git on our own, we should have like a follow-up and try to like work on the project a little bit like a silly project, but just something collaboratively so that we can see how we can work with each other and how the changes actually work back and forth. Yeah, I kind of needed to establish a little bit of background in this very complicated language. So yeah, that's my crash course. 1 hour instead of 3 days. Any questions? I'm assuming probably yes, but I have no idea how to even ask them. So that's
Yeah, but it was a nice introduction.
Yeah.
I know more now than I did an hour ago.
which is good. But it is like most things, like you have to work a little bit with it and try a little bit back and forth before you start really grasping how it works and why it's meaningful to work with. But really, like it's really this like not losing the history of something that's nice. It's so many times I write some code and then it works and I go back and I do something like I change the code and then after a while I'm like, oh, I really regret that. Like I wish I want to go back to what it was. And with Git, I can go back to what it was. It's a little bit of work, but it's actually possible to go back, like to completely go back to something, to a state the project was in before, because you weren't in your right mind when you did something. You decided to fix a problem at 2 in the morning. Then and then you're like 2 days later you go, oh damn, that was not a good idea. I want to just forget everything I did, and you can, which is really nice. Yep.
Nice.
Cool.
Thanks.
Thank you. You're welcome.
Very nice.